Hello grade 9s, welcome to today's Maths Lit video lesson. I hope you all are well. In today's lesson we'll be covering the final part of the data cycle, which is reporting the data. And this can be found on page 291 of the textbook. So we make a report on our findings after having gone through the entire process of the data cycle. And just to refresh, our data cycle started with a problem. We had a plan as to how to tackle this problem, what kind of data are we going to collect, what kind of survey are we going to do. Next stage was organizing and summarizing the data using a stem and leaf plots or tables. Our fourth stage is representing this either using a pie chart or various kinds of bar graph or straight line graph. And in our last stage, we interpreted and analyzed the data using measures of central tendency and range. Remember, measures of central tendency tell us what the data is doing overall, and our range tells us how spread out the data is. And lastly, we make a report on these findings. Starting off, we're going to discuss how outliers affect the measures of central tendency and our range. Remember, outliers are extreme values. They are either much higher or much lower than the other data points. And this will affect our calculations for mean, median, mode, and our measure of dispersion, the range. Here I'm going to use a simple example. We have the maths marks for 5 learners, and we can see that our outlier is this 17, which is way below the other marks. So I'm going to do the calculations for measures of central tendency when we include this outlier, and then I'm going to compare it when we do the calculations without the outlier. In this case, mode is not really applicable as a measure of central tendency because each of these values occurs the same number of times, which is once only. If we recall, mode is our most common value, and all of these occur an equal number of times once, so any of these numbers could be our mode. Let's find the median and mean with the outlier. So remember, our median is our middle value. And firstly, we need to organize this data from lowest to highest. So it will go 17, 40, 54, 63, 78. And now that we've ordered them, we can see that our middle value is 54. To find our mean, we add up all the marks for the 5 learners and divide it by the total number of learners. So the mean is the sum of all the marks, 17 plus 54 plus 40 plus 63 plus 78. And we divide it by the number of kids in the class, 5, to get a class average. Adding everything up here at the top, we get 252 divided by 5 gives us a class average of 50,4. Now let's find the median and mean when we don't include the outlier. So what we would expect the median to be a higher value because we've excluded our lowest value. We'd also expect our mean to be greater because we don't have this 17 dragging down the class average. Now when we do our calculations without the outlier, we exclude the 17 and we find our mean and median in exactly the same way as we did before. So to find our median, we need the middle value, and we first need to organize this data from lowest to highest. So it would go 40, 54, 63, 78. And the median is our middle value, which lies in between the 54 and the 63. So it would be the average between 54 and 63. So to get the average of these two values, we just add them up and divide by 2. and this comes out to 58.5. To find our mean, we add up all the class marks and divide it by the number of learners. So we're going to add up 54, 40, 63 and 78. And now we're going to divide by 4 because we've excluded one learner. So this gives us 54 plus 40, 3 plus 78 equals to 235. Divide by 4 gives us a class average of 58,75. So I'm just going to rub this out and write it next to the results we got with the outlier. Median is 58,5. Mean is 58,75. And if we compare the two, we can see that yes, indeed, excluding the outlier has made our median higher and our mean higher. So when we're reporting this, we would have to explain whether we are including or excluding the outlier and give our justification for doing so. So for example, the mark of 17 might not be representative of the overall marks of the class. There might have been certain kind of issues like health issues or changing schools, and that's why this learner did so badly, so it wouldn't really be relevant to the school's performance. We can see another example of the impact of outliers in the worked example on page 291. In the scatter plot, we can see that the first 3 points are very low, much lower than all of the other marks. And if we include these outliers in our calculations for measures of central tendency, we can see that they pull down the mean, they pull down the class average, and they also pull down the median. In the next worked example, we see how the data can be used to establish a trend and how this trend can then be used to try and predict what will happen in the future. This graph describes population growth of bacteria over time, and we can see that as time passes, the number of bacteria increase. On the horizontal axis, we have our time measured in seconds, and on the vertical axis, we have the population of bacteria in thousands. So where we see the 7, it would represent 7,000. Our existing data is only up till time 20, and we can guesstimate what this population is doing. It's growing in a linear fashion. So we can plot a straight line through our data points. That's our trend. And if we follow this trend to the 30-second mark, we can make a prediction that we get just over 7,000 bacteria. In the textbook, they say it should be 7,200. Lastly, I'm going to do a problem from exercise 24.3 on page 292, and we're going to look at question number 2. So it asks us to consider the data graph, and we can see that on the horizontal axis we have years, and on the vertical axis we have number of lion cubs. So this shows us how the number of lion cubs changes over the years. Question 2a asks us what does the data represent, and we would say number of lion cubs born per year from the years 1990 to 2004. Question 2b asks us whether using a broken line graph would be better than using the scatter plot. If we remember, a broken line graph is where we just draw a line joining the points, and in this case using a broken line graph might be better because it more clearly shows what the data is doing, how it's fluctuating over time. Question 2c asks us to determine the mean number of lion cubs born in any particular year. So we need to find the totals for each year, add them up, and divide them by the number of years, getting an average. The first data point is for the year 1990, the first year, and if we read off the graph, there were 5 lion cubs spawned. In the second year, in between 1990 and 1992, that would be 1991, we have 7 lion cubs. So mean is adding up the totals and dividing by the number of years. In the third year, 1992, we have 2 cubs, and so on and so forth. I'm just going to pause the video and fill in the rest of the values for the other years, and then we'll continue. So I filled out the values here for each of the years, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 values. So from 1990 to 2004 is 14 years. And if we work this out, we get our numerator, the top, as 5 plus 7 plus 2 plus 6 plus 8 plus 7 plus 6 plus 15 plus 9 plus 7 plus 9 plus 8 plus 7 plus 6 is 102 divided by 14 is 7,28 cubs per year, and we would round this either up or down. If we wanted a whole number, we could say there's 7 or 8. So let's just check this answer. Yes, it's 7.28. Question 2D asks us if there are any outliers in the data, and yes, we can see 2 outliers, one in 1992 where only 2 cubs were born, and another in 1997 where there was a much higher number of cubs born, 17. 2E asks us, can you give possible reasons for these outliers? So for 1992, when there were a few number of cubs, you could say there was a shortage of food, for example, or you could say something like poaching, any valid reason. And similarly for 1997, when there were many cubs born, you could say maybe there was an abundance of food. Question 2F asks us to find the mean when the outliers have been removed, and also to discuss how removing the outliers affects the extreme values. So I've rewritten the equation for the mean, including the outliers, and if we exclude them, we remove the 2 and the 15. And because we're taking away 2 values, we're now just dividing by 12. Let's see what this gives us. So our numerator at the top is 85, and we divide it by 12, gives us 7.08 cups. If we're looking at the effect on the extreme values, 2 was our lowest value and 15 was our highest value. And when we remove them, our highest value is now 9 and our lowest value is 5. So it means our extremes get narrower, they get closer towards the mean of 7.08. Lastly, question 2G asks us to write a short report on our findings, and to make a prediction of what the lion cub population will be in the next year, 2004. So our report will say whether we are including or excluding the outliers. There might be good reasons for excluding the outliers. Maybe they just are not representative of what the overall data is doing. They are just too extreme. To make the prediction for the year 2004, we could use the mean, 7.08, excluding the outliers, or we could look at this data, which does something like this, and we can say it looks like it follows a linear straight line horizontal pattern, and our next year 2004 will lie on the straight line, probably close to 7.08. So that concludes today's video lesson. I hope you guys understood what was going on. And once again, there's no homework on this. Just follow the theory, follow the worked examples, see if you can match the calculations. So thanks guys, thanks for watching, and take care.